Welcome to Basic Integration Examples. This is part 4 of the Calculus 1 review. For your first example, find the following indefinite integrals. First up, part A, find the integral of 2x cubed minus 4x squared plus 1 dx. So for this, we can split the integral if you wish. Integrals can be split across linear combinations. We could view this as 2 times the integral of x cubed dx minus 4 times the integral of x squared dx plus the integral of 1 dx. X cubed, x squared, and 1 all follow the power rule. So x cubed, we'll have 2 times, we'll do x to the 3 plus 1 divided by 3 plus 1. Then we'll minus 4 x to the 2 plus 1 divided by 2 plus 1 plus integral of 1 is just x. 1 is x to the 0th, so essentially we're looking at x to the 0 plus 1 divided by 0 plus 1. Then, of course, we have our plus c at the end. You do not have to write the integral all broken down. You are welcome to just skip straight to 2 times x cubed divided by 4 minus, 2 times x to the 4th divided by 4 minus 4 times x cubed divided by 3 plus x plus c. Those of you comfortable can jump straight from that the problem statement to this final answer. Of course, if you wanted, we could reduce that first fraction to just x to the 4th over 2 minus 4/3 x cubed plus x plus c. Next up, let's take the integral of 2 over t to the 5th dt. So note, this is precisely the same thing as taking the integral of 2t to the negative 5th dt. So this is a hidden power rule. This will go to 2 times t to the negative 5 plus 1 as our exponent, divided by negative 5 plus 1, and then we have our plus c. And we wind up with a 2t to the negative 4th divided by negative 4 plus c, otherwise known as negative 1/2 t to the negative 4th plus c, or negative 1/2 times 1 over t to the 4th plus c. Next up, we have our cosecant squared x dx. Take integral of cosecant squared x dx. Recall, this corresponded directly to the derivative of cotangent of x is a negative cosecant squared x. That's where this particular integration fact is coming from. So we have that the integral of cosecant squared x dx is just a negative cotangent of x plus c. If you wanted, we could rewrite the in-between integral as the integral of negative cosecant squared x dx, just to see precisely where that negative cotangent comes from. Next up, we're going to look at a slight variation of these examples. We are starting with the derivative of a function and an initial condition or initial conditions, and then solving for f of x. So part A, we have f prime of x is equal to x to the 4th with f of 0 equals 5. So if we know the derivative, we know that f of x should be an integral of f prime. So f of x is an integral of f prime of x. So we are looking at an integral of x to the 4th dx. Integral of x to the 4th, we're using our power rule. X to the 4th goes up to x to the 5th, and then divide by 5. plus c. Then we will go ahead and use the fact that f of 0 is equal to 5. So we have f of 0 is 0 to the 5th over 5 plus c should be equal to 5. That means our c is equal to 5. And we wind up with f of x is x to the 5th over 5 plus 5. Part B, we have f prime of x is cosine of x, and f of pi over 2 is equal to 3. So once again, we have f of x should be an integral of f prime of x. So f of x should be an integral of cosine of x dx. Integral of cosine of x was positive sine of x plus c. Then we are going to use the fact that f of pi over 2 is equal to 3. So we have f of pi over 2 is sine of pi over 2 plus c should be equal to 3. Sine of pi over 2 is 1. So we have 1 plus c equals 3. That tells us that our c should be 2. And our f of x is sine of x plus 2. Next up, we have f double prime of x is equal to x plus 2. And we are told f of 0 is 1, f prime of 0 is 3. Integrating once takes us back to the first derivative. So we have f prime of x should be the integral or an integral of f double prime of x dx, given that the derivative of f prime of x is f double prime. So we are looking at the integral of x plus 2 dx. We get a general answer of x squared over 2 plus 2x plus c for f prime of x. Then we will go ahead and plug in our known fact about f prime, namely f prime of 0 is 3. So this tells us we have f prime of 0 is 0 squared over 2 plus 2 times 0 plus c should give us 3. And we get that our c must be 3. And we have f prime of x is x squared over 2 plus 2x plus 3. From here, once we know f prime, we can once again integrate to find f. So we will integrate again to find f. And we have integral, so f of x should be equal to the integral of x squared over 2 plus 2x plus 3 dx, or it's equal to an integral. Again, applying the power rule, x squared goes to 1/3 x cubed, or x squared over 2 goes to x cubed over 6. X goes to x squared over 2, so 2x just goes to x squared. And we have plus 3x plus another c. I'll just call it c1. Again, we'll go ahead and plug in f of 0 equals 1. So we have f of 0 is 0 cubed over 6 plus 0 squared plus 3 times 0 plus c1 should be equal to 1. This gives us our c1 is 1. And we wind up, therefore, with f of x is equal to x cubed divided by 6 plus x squared plus 3x plus 1. So again, this is a very basic integration problem using integration facts that we already know, and how we can go about taking these integrals or solving for an initial function given a derivative and an initial condition.